am I audible clearly?
Yes, but you have to raise your voice a little bit.
Sir, is my screen visible?
Yes, visible. I know.
Hi, sure. Hi, everyone.
Sir,
Hello,
this is
Narayana.
So now
this is the
Nike is
code.
presenting like filling up of the null values on the AQI, and he has some
Okay.
queries. He posted so many things in the group, right? And but he told he achieved it. But we will quickly wrap up. It is not much lines of code also there.
Okay. Okay.
Go ahead,
Okay.
Nike.
Sir, here is the in first we are importing the necessary libraries.
Yeah.
After that, I am reading that CSV file.
Mhm.
Then after that, I am just replacing the all the terms like insufficient data for computing with
Mm.
nan values,
Mm.
no value one with nan values, no data available with nan values.
Can you add one more line here? Like
Which
replace
one?
none with np none. The one which I have coded you, right? In the WhatsApp.
Yes, sir, but I think there is no none values.
No, the white space, na, it will take like that only. Just add that one line of code.
Okay, sir.
That none is okay. That is okay. Plus is equal to true. Then after that, can you execute? Since you are modifying it, can you execute them?
Yes, sir, I executed it.
Executed also? Yeah. Okay.
Yes.
Uh,
After that, I am just taking these two columns, date time and AQI,
okay.
and
But what about
we
the index? Why the index came in? Okay, while reading itself, you haven't assigned that date time as index, right?
no, sir.
Okay, that will be also okay.
Okay, sir. After that, I am calculating that the null value is at 7,466,
Okay.
and I am just here replacing the null values with zero because for that problem.
Okay, can you just bypass this one and let's see what was happening?
Okay, sir.
You have executed till top line, right? Okay. After that,
Yes.
here just put np dot none. It's not np dot
Sir,
none also, I think. What we have to do right here?
sir, here what I have to write.
So keep np none.
Sir, it is not getting.
So this is what your
That's why I have
and Lakshmi,
replaced the.
how we will define here, like only none none or np dot none?
Uh, yeah, this one NP dot none only.
But why it
You
is
can
creating
also
error?
use a single quotation error where I not seeing error.
See, error is like in the top row 165 output, it is saying like 7466 values are null values. Okay. And here when we
Is
are
null
filtering,
values.
it is saying
Oh,
blank.
then we'll see, right? DF, can you put this one equal to true is null equal to true? We'll do that. Okay. Okay. No, we go down the same statement instead of putting equal to true. We should make it as a true. Like is NA is null is okay. You are checking is NA, right?
Huh.
Then we will make it DF is NA true. Can you make that one? Dot dot is NA, yeah, quotation equal to true. Or just equal to, and without true also, just to put that, no need of equal to, delete np dot nan, run that.
Sir, do
Equal,
you want
delete
to
equal
the
to, delete
No,
equal to.
delete double equal to, yeah, yeah, run it. So it is like nan. So you should give as nan now.
My, my,
Are
my,
you?
my question is np dot
Hmm.
none, whether it will not like match. Why that error got this is one way we will proceed, but if we want to use
Hmm.
is equal to, we have to use like none none or like np dot none, or how it will be, what exactly that
np dot n only, which we did. Let me check once my scripts.
yeah, meanwhile you carry on, Nike.
yes, yes. After doing that, I am just splitting it to 50%.
Hmm.
DF temp. I have just taken it just for now.
Okay.
And in train X, it will take the 50% of these null values.
Okay, so in any 1% we can take it, that is not a deal since it is 50%.
Yes, sir.
Hmm.
After that, I'm just storing the all the train X date time in
Ah,
a variable RTD
okay.
and setting the index of date time in first data frame which we have loaded. I
Hmm.
am just setting the index as date time. Then
Ah,
after
okay.
that,
Hmm.
I'm iterating through this RTD and
Ah.
df dot drop x comma in place equal to 2. It will
Here I think we can pass directly list.
sir, which one?
The df dot drop you have placed it, right?
Yes, sir.
So instead of x and making a loop, right, you can directly write that list of that variables. Try to print that RTD, what it is. It is giving list.
Yes, no, 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 sir.
It is giving series, right?
Yes, sir, series.
It is giving series. Okay. So
You can typecast it.
no, list means again it will come. It is not uh, the way. No, dot index actually it has to come, right, where you have set the index for RTD. For this one, what I have told you, you just keep index for RTD, keep index as a date time column, and make that index as some variable.
Okay, so, sir, is it we can also do it by this typecasting
For
method?
loop is also one approach, but since loop now, when you make loop, the time it will take more, so it is not a good approach. When you have other
Sir,
things, no, it is not a good approach.
yes, sir, but it is now converted to list, na?
Just print x, you can see that index also, type x, only dates are coming, nothing else. Then it is also
Yes, sir.
okay, then it is also okay. I think maybe since it is a series, it is giving list. For data frame, it will give that index also. So I got confused
Yes,
with it.
no.
That is also okay. Just try to pass here that Excel. You can modify the code, whatever terminology, you can keep it later. Not accepted.
Not found in it.
Just try to like take help of there, like tab, click tab.
One second, I think something is I have to read.
Oh, that also good.
Yes, now it's okay.
Now it's okay, right? Try to check whether the dropping of values was happened or not.
Mm,
Definitely it will happen. So you should see some gaps at least. So 0 to 8 it is there, jumped. Okay, there it was dropped. The first
yes, sir.
and second one.
23291
Yes.
goes as
So
well.
okay, it is clear. No, go ahead. Go ahead.
27044.
So this you can delete it now. Mm. So
Sir, it is, I am giving the first variable as something dummy because first row contains null value. Okay,
okay,
sir.
that is also okay. Instead of giving that value, right? Take the value, random value from that one, or take some median value, something that will be good approach. Because this is
Okay,
manually you are editing, right? That is not good. Whenever you are taking some other data set, it should not ask for the value. It has to take like from AQA, take a random value or take any mean or median, whatever it is. That will be also good.
okay, so sir, is it okay if I will take the median or mean of
That is okay.
nearest
Only one
7?
value you are modifying, right? That is okay. Don't put like manual editing. Take that value so that when you are rerunning it, even with other data set, it will be like unique. No need to change
Okay,
again and again. Okay, for
sir, I
time
will.
being, you leave it, no problem. But you make a note and you change it. Or else, if you will not take time, you just try
Okay,
to change it now also.
okay, sir, I will take the mean of first nearest 7.
That is also okay.
Okay,
Try to execute now. We will try to share this final sheet to Sripati now. Since he is also going to demonstrate one by one, we will go to check.
yes, sir, it's complete. Now it's 0.
And no negative values, right? Kima, since you are using a Kima, I have a doubt. Any negative values came.
Okay, sir, I am opening that file.
And this code now, whatever this 420 value, you try to change, and wherever you want to give comments and try to push in the Git.
Okay, sir, okay. No negative
No
values are
negative.
there.
Then it's good. Then it's good. Try to paste this in WhatsApp group now, so that
Sir,
Sripati will take
which
care of.
one, this file or code?
CSV code you directly
Yes,
upload in Git. Okay, there is nobody
File
is going to.
for time being, you give file first. I will just put the same file in the code which we were trying in the morning.
yes, sir. CSV I had shared in WhatsApp
Now
group.
you share it
Uh,
one more time, no problem. Since
okay,
it
okay,
was
sir.
seen now, right?
Okay.
What is the same one you're telling, Nayak?
What, sir?
Uh, it's the same sheet again you are sharing already, which you have done a little while
Yes,
ago.
yes, yes, sir. Yes.
Okay, okay, okay. Anyway, if it is handy, then post it on the WhatsApp. If it can be
Share.
done comfortably.
I'll share it again. No problem.
Yeah,
Okay,
share it.
okay.
Share it. So meanwhile, make Sripati as host. Where is
Hmm.
Okay.
Aman? He is supposed
Yeah, I
to be
was
there, right?
thinking. Yeah, Aman is now joining.
Not joining.
Yeah, he joined.
Where? Yeah? I cannot
Better,
see.
better. Aman can
Oh,
use this
he is down the
stage.
line. I didn't able to see it.
Aman,
Yes, sir.
are you ready with the code? Just like Subrat, what he did, he has shared a new set of files. So
Yes, sir.
if you can share screen and try the code for checking the stationarity,
Yes, yes.
okay? Because morning, Ishwar, what I did, like I called Naman and shared the plan, and after doing the stuff, I have given it to him just to do anything like further he wanted to explore anything on top of it.
Yeah.
Because when I checked the seasonality, no, it was the stationarity we was particularly it was looking good that time with
Okay.
the data which I had. So with the current one which Subrat is sharing now, could be like we'll be on the same stage.
Okay.
So and then there is nothing much to do on stationarity part. So we will move to the next level. We have the plan. We will discuss after that.
Okay, okay. So
Yeah,
he shared that file also.
yeah, yeah.
Aman, you can take.
Aman is the host now. Aman, you can
Yes.
share your screen. Who is not joining today? Like,
Ravi
no.
Teja, he told for 2 days he's like out of
Ah,
station.
correct, correct. Ravi is missing today. Okay.
Actually, I have summarized what are the steps, what are the prerequisites needed for building our
Ah,
Arima time series model.
correct,
These
correct.
all
This is
are the
what.
steps.
Yeah. So, Aman,
Uh,
this we will discuss after the validation. You better start validating again the current data which it's been shared.
okay, give me a few minutes. I have.
Yeah, yeah, yeah. So, if things are moving in this way, Ishwar, so we are almost now getting closer.
Yes, I feel like within 1 week now we can able to complete, because once this
Because,
part is like confident enough, like the accurate enough we go now, then the
hmm,
modeling part, it is like 3 4 lines of code. Then see the accuracy,
hmm.
rerun the model, tuning part, it will be only
We,
20 minutes.
yeah, yeah, we have to try a couple of models. The plan is uh, in this group, we will again form a group of two people and we'll be giving one model each. They will explore that. They will bring out the result and sharing together. We'll decide the best one out of that.
Means
That is
in
the
the
plan. Everybody will
in
work
that
on the
group,
model part.
you mean to say, right?
No, no, no. The here only.
Here
We
only.
are going to do.
Yeah. Okay, that is also good.
There it is okay. There, whoever wants to do, let them do. I am worried about our group.
Yeah.
So what I'll do, like, we'll form two people each. I am working with Aman, so you will
But
take.
at least have you listed out these models? What are the models you
Yeah,
are
yeah,
working
that is
on?
what. That is what. Yeah, we have. So we will
Okay.
be like we want teams voice
So you
on
are
that also.
talking about this on Sarima models, that Arima
Yes, correct.
models.
Sarima is
Arima,
there, Arima
Sarima.
is there,
Okay.
LSTM is there.
Hmm.
Yes.
Then
Okay.
so many are there.
But
So we
I
have to
have
choose.
seen most of the things is most of the guys was done with LSTM, right?
Yeah,
LSTM, yeah.
LSTM.
So that
Yes.
is
It is
also advanced, I
the
think,
best.
among all.
It is neural
LSTM
network.
is deep learning
Yes,
model.
deep learning
Yeah, it
model.
is a
Yeah.
neural network. Yeah.
Hmm.
So that we will keep it in the last. Since we are in the learning phase, we don't want to hit the bullseye directly.
Mm-hmm.
We'll do like incremental way. We will do it. Yeah.
So this is the data
Maximize that
which.
screen. Maximize that screen.
Okay.
So data you have to you have to make it available, Aman. The one now Subrat has given.
Take
No,
that.
Remove
first
this
I'm
AQI.
the data which you have given.
No, no, no.
Now
First
That
I'm
now we have to take it out.
okay.
take the data set which
Just
was shared by Subrat Naik.
Okay, okay.
Subrat. Yeah.
Just
In WhatsApp chat you can see when the new data set is there. Download that. Rename it as again AQI. You need not have to change in the code. Only you have to add in the folder, collab folder only.
okay.
Got the point? Don't change
Yes,
anything
yes.
in code. Rename the file as AQI and add in the collab folder. That's it. And remove the older one from collab to avoid any confusion. So that is where is like models are there. We will be approaching with the basic, like Arima is the basic, and then Sarima is also there. Like it's little tweak in that, and then there are some other also. I have seen few been done. A regression is also getting used for time series, so that is also we can try. So 2, 3 we will try like that, and then lastly we will also try LSTM, and we
Yeah.
will see overall the result. The best one we will opt and then
That
validate.
is also,
And also the plan is not to make model here. The plan is to deploy it on cloud also.
correct. That is means if we are going with only that score value, na, nobody bothers. We have to deploy it.
Correct. We have to deploy it on the cloud. We'll make it as a kind of like a product, like a tool. If possible, we can present some UI on that, like user interface for that application. Then it is going to be a great stuff. Like we can
Yes.
say it's a kind of complete project.
My view na means even not the short term one. This project,
Mm.
like even I have shared some screens in the group also. Like in mobile, we are getting that updates, okay, on daily
Yeah, and
basis.
MI, yeah, and
MI
nowadays
phones.
we are getting,
So
yes.
like that, we also make somewhere like even web or mobile, whatever it is, we have to make some updation, auto updation of every day at least. If you can able
We
to
can
day
explore.
every hour
Yeah,
also we can make, that is different thing.
we can explore what after the model is ready. No, we can explore the next level of thing, like how it can, because this is just the core part we are doing of AI. Then AI is having multiple factors, like how the infrastructure will be, where we are deploying it, who are our end user, how to end user we are going to publish this. So there are things. So those things will start
Because
discussing
we
once.
up to this level,
Yeah.
right, modeling everything,
Hmm.
we are very much familiar with, means there's
Hmm.
still lags
Hmm.
are there, but we are very much,
Hmm.
but the other part deployment also most of the guys are familiar with, but like
Hmm.
making like that repetitive like process, right, not repetitive, I can say live process, live updation, that is
Hmm.
na, nobody have tried, I'm sure, okay, that
No,
we
no,
have to at least.
whatever, yeah, whatever new we can try, new things are needed. Please suggest also. Like even
my
it's not
my
like
option, no, it is like, so it's not one time, it will be like everyday updation, at least we have to try, and we have to like it in back end it should run. I don't know whether Heroku will be running or is capable for the free versions.
because we need storage. We need storage in that way. How it is going to be.
Why we need storage for that?
See,
It 2 GB is more than enough, right? They are
uh,
giving like 2 GB
but
or something, I think.
cloud that
Info.
Heroku is free, freeware.
Heroku 5 apps are free, but I am not sure
Uh-huh.
that what type of code inside we are allowed to run.
Uh,
Okay,
okay.
deployment wise, Spark we have tried with time you run. Okay, but rest of
Okay.
the thing I'm not sure.
Mm-hmm. Got it.
So that one it means it has to update on a frequent daily basis, and we have to provide a UI where people can go and search for like the future values of the equation. Like CPC, we are going only for current values, and in weather forecast, in MIUI, it is even forecasting also.
So
So
we have to make a scale in a way, like once like whatever the coming time is there, like let's say for January, if we will predict now only, and when January that date will come, we'll try to match what our model is forecasting is close by or not.
correct. That is the accuracy thing. Okay. Even
Yeah.
we will train the model with till November, and with December data we can predict it. That
Correct.
accuracy
Correct.
part during testing we will be carrying out. That is different thing.
Mm, mm.
And after that deployment level, what my idea is to make it like update automatically on a daily basis, so that anybody can come there and see that okay, maybe tomorrow I have to carry
Update
mask,
you
like that.
update the data state you mean to say?
See, if you go to CPC website, what you can
Huh.
see the past history of the data, right?
Uh-huh.
Like that way, whatever we are giving, like URL, if people are
Uh-huh.
going there, there automatically they have to see the future values. They should not click any button. Okay, the data
Okay.
like what you say dashboard. The dashboard should say that the future 1 week values or 1 month values will be like that.
The way we are having weather forecast, the same way it should be highlighting the
Yes,
AQI
correct.
forecast.
Yes, correct.
Got the point. The moment in the mobile we are seeing, no, for next 15 days they are forecasting this is going to be the situation.
Yes.
Same way
Because
the
like that UI I haven't seen for AQA especially. Only in MI mobiles I am seeing.
okay.
Nowhere else.
Okay, got the point. Got the point.
Then, sir, we have to also update our data set also.
Mm-hmm.
because training, if we predict
Oh,
tomorrow, that is
he also
wrong.
did
Then
the
we have
same thing again. Why 50%
Who?
kill something?
I have not done. I've
No,
taken
the
the test.
name is like that.
Oh, changing the
File
name. You
name,
can,
file
that is
name.
what he told now. Change that rename in your system itself that file name to AQI. Then it will be like
No,
okay.
no, it's okay. Now he imported the same thing. It's
Uh-huh.
okay. It's not going. Yeah, run the logic. Yeah. So head is okay, and then
Then this column part,
yeah.
it, I think it's not here. Columns are
No,
not
Okay,
named.
we can keep one that we can keep it as a names. Columns we can keep it one. We can initialize one name. Columns equal to
in pd dot read csv na there
yeah.
put comma after that columns you can
No,
index
no,
column I
column
think.
is not there. That is a name. Name equal to
Name is equal to.
yeah name. Name equal to bracket like a square bracket. You can give date,
0.
single quotation date, and comma, no daytime, comma, single quotation AQI. I run that now.
No, he wants to make it index also. For that I am telling.
Oh, index. Okay.
There is
Okay.
like index column like that one more name it is there.
No, there is
Okay.
no name.
It
Not
is there. I have done already.
Okay.
Is okay. Is a names. Okay, not the name. Just a names. Okay.
Name yes.
Index name yes. Okay.
Okay.
Sorry.
Even in there now, if you want to make it that date time as an index, directly you can do it there itself. In p dot.
Index column, index call, something
Yes,
like
correct.
that.
So if you are running all these, then it will come as a column. You already done it. Yeah, set index.
Yes,
You are
yes.
doing it here. Okay, the results. Okay.
So this
It's
is
not
this is
stationary data.
yeah, it's not stationary. Because earlier one it was looking good. You can go with the graph.
Bell-like shape. It was bell-like
Yeah,
shape.
yeah. It's
Because their full data is there.
okay.
Na? Now we are dropped some data.
Now looks like good. We can see the value.
Decay for the test.
Yeah. And the mean value also we have tried, na? That also we can
Yes.
give it. See to like
Almost similar.
yeah,
But
it's looking good now.
variance is fluctuating.
Little difference. Yeah, variance is like a difference of 400, 500 something.
P-value and ADF test of look.
P-value 0.
Looks like good.
No, with the
Actually,
second
it's
code.
giving 0 because it is in exponential and it is float value. So that's why it's giving 0. Here you can see
So
the
it is
actual value.
like stationary.
Yes.
Complete stationary.
Yeah, P0 is stationary, right? Yeah.
It's like very small as expected. So what we have done, like the first one when we ran the logic, that exponential thing what Aman said, because of that p value was not coming. So again, like another, no, we tried to define the AD filler and then given the test data there and tried to run for getting the p value.
Actually, in decay fuller test, we basically see this value and it's this is t
That
value.
1% correct.
And it should be less than this critical value. This value should be less than this critical value. And p value should be less than 0.05. So you can see it from here. It's in exponential minus 0.8. So it is very less.
Go through the code. Means if you are okay with from top to bottom, right? You have run and you are clear with the things, then just start from the top. So now
So you make a go through of the code.
So that everybody will get clear idea. If somebody have doubts also they can ask at that point.
Yeah. So Aman, you start from the top.
Okay.
And
Just uh, want to make that what I have done.
Yeah, that's good.
Yeah.
You done with your things, and then we'll discuss.
So autocorrelation also you put.
Yes, yes.
Good, good. That is where I thought, like, that till that point I have done, I thought of asking. That's the reason I asked you, like, you can add your point, whatever you wanted to check further. Because we want 100% confidence on the stationarity thing, like,
Yes,
before reaching
yes.
to the model level part. Submitted as
I'm
well.
sorry for that.
AQI log.
I have not changed it.
Mhm.
See this. This autocorrelation, it's not going downwards. It's showing only in upwards. So our data is not stationary. It is stationary. That was same case which the data you have given earlier. That was also the same case. Here, Dickey Fuller test shows that the data is stationary,
Hmm.
but autocorrelation should be like this. At least it get downwards so that we can calculate the p value and q value. But it's not going downward. Now we have to transform it into stationary by doing a log transformation.
Did you try
Like,
that or
yes,
want
yes.
to try?
Yeah, I have tried it also.
Yeah, yeah. So morning, the data which we were working that time, autocorrelation was doing good.
No, autocorrelation for that data only I have tried for autocorrelation, but
Uh-huh.
it was giving same graph.
So there is not much change in the data.
Yes.
Yeah, yeah. So we have to explain the logic also, like what we are
Yes, yes,
trying
yes. I
here.
will
Aman,
explain
yeah,
it.
yeah, yeah. That is good.
Now, if we try to build it, now see,
Mm.
autocorrelation is now
After applying log transformation, it
downwards.
is like good.
Yes. Mm.
Yeah, this is
Now
the
I will
expected graph.
explain from starting what I have done. First, after null values, we have to check for the stationarity of the data. So stationarity of the data can be checked through this way, either by using graph or histogram. Histogram, the shape of histogram should be like bell shape,
Bell.
normally distributed.
Correct.
The graph should be there. So by seeing the graph or histogram, it's quite difficult to observe whether the data is stationary or not. So we have mean also to calculate mean and variance by splitting where it is gone.
Go down, go down. It is good. It is after this graph.
Yeah.
Yeah.
So we have another method, statistical method for seeing the stationarity. We have what we have done is we have splitted the data AQI into two parts, into three parts. 25% of data for length of data and 75% length of data. And we have calculated the mean and variance of this data. And if mean and variance of this data are approximately similar to each other, then we can also say that the data is stationary. Like in this case, mean is similar, but variance is fluctuating.
Hmm.
So
Here for
data is
calculating
not.
mean, there is a, like a rolling average. We can take it, right? Even we can visualize also that one
Yes,
thing.
yes, that's also a way to check for stationarity of the data,
Mm.
moving average or rolling average.
Mm.
Yeah, yeah, that is another way of doing it. We
Yes,
can try that
there are
also.
different ways of finding stationarity, and another
Because
way is
sorry to
Dickey-Fuller
interrupt,
test.
what I have seen is there now, they have shown where I have referred, they have shown like the graph how the uh, rolling average or mean it is going, and how the standard deviation is varying, and what is the actual graph. These three they have compared and they have shown that visualization really make more sense, like
So want
instead
to
of
try now,
numbers.
then we can try. Want to try now, then we can put that code, no?
That means let him
Yeah,
go through.
there are different
Uh,
ways to calculate,
let
to
him go
test
through,
the
then
stationarity.
Yeah.
whatever points now we'll make a note how much we can do it here, rest of the thing after the meeting he will work out and he will come.
Mm-hmm. Yeah,
And
yeah, man. Carry on, please.
another way is Dickey-Fuller test. Dickey-Fuller test, in if we go from mathematical terms, then it's very difficult to derive, or it will be very lengthy and mathematics all involved. So what I found about that is, we calculate here what we get the ADF statistic or T statistic, we can call it, and the value of T statistics should be less than the critical values, that is
Right.
1%, 5%, 10% of data, like it is -3.
So
So
where is
and
that
it is
value
-6. So
minus
this
6 is that t statistics or adf statistics?
Yes,
is
yes, yes.
So you mean to say
and
adf is
there is
the
also,
t statistics value?
yes, ADF statistic is T statistic value,
Okay, okay.
and it is now here it is critical value. It should be less than this value. So -6 is less than -3. So stationarity is maintained, and we also check for p value. P
Hmm.
value should be less than 0.05.
Hmm. But
So
I am
here
surprised why it become that much very near to zero. Normally it should not be like that,
yes,
right?
it's actually near to zero, but it should be less than 0.05. So it is satisfying, the both the condition is being satisfied.
My question is that p value it is showing like zero, okay, but normally in general case it will not be zero. It will be like
Yes,
above
yes,
the
you
zero
are
and
right.
below zero point 0.5 or somewhere
No,
near.
no. Here, I think the print statement what we have taken, no, could be because of that it is happening. So we have to
Floating
revisit this
here,
part.
floating is taken now. So
Correct.
Take some 3 digits or 4 digits, then it will be okay. 2f something you have to put, I think. 4f, make it 4f. That also
2f will till decimal 2 point only.
yeah, 4f you take it.
Here the value is very much less. Yeah, as you can see here, it is going in
-8.
uh,
Yeah,
8th.
yeah. It's at
Oh my god.
-8.
Mm.
Hmm.
Okay.
So
So
that's the
that's
reason it
why.
is assuming zero
Means
there.
my question is whether really we will get like that value, or there is some mistake happen. That is what my confusion.
No, no,
Be-
it depends upon the data.
Okay, so our data
It's
is
not
nowhere.
like
It
that.
is
It will
like
all.
seasonality. It is like more
Yes.
So
stationary.
it's moving towards
Stationary.
stationarity. That
Hmm.
yeah.
But as per histogram and other mean is not stationary, right?
No, mean
Yes.
it is showing. Mean it is saying correct. But again, variance when we have taken, no.
Okay.
So there we have seen
Okay,
like
that is okay. That is
fluctuation.
not stationary. Okay.
So
Hmm.
mean is stationary and histogram is not stationary, correct?
Yeah,
No,
histogram should be having a bell
mean
kind of structure, like normal distributed form.
Okay.
normally distributed. Yes.
Yeah.
Because of missing data, maybe it is unable to show that.
Decay test is showing that data is stationary, but actually when we plot ACF for autocorrelation and for calculating model part for Arima, here it shows that it's actually fluctuating. You have saw the graph. It was going a straight line, but it should not
Aman,
be so
we
much.
have to keep that code as well to just say like where autocorrelation is highlighting that it is not stationary, and then what we are trying to mitigate that and bringing out the right
Okay,
result.
I will include that also.
Yeah, kindly put that also. Yeah.
Yes, yes.
And this
After
critical
if
value means
if data is or not,
sorry Aman, that critical value whether
yes, yes,
it
yes.
has some meaning in it, like you are saying okay we will compare and it should be less than that, but what that critical value says?
It is
Critical
having a
values
definition. Yeah.
mean critical.
Carry on, Aman.
There is a table for Dickey-Fuller test
Mm-hmm.
in mathematics.
Mm-hmm.
So the in mathematics it is given that it should be less than this value.
Okay.
The critical values which are 1%, 5%, 10%. Like in statistics there is table for T statistic, F test, T test.
Correct.
Like that for Dickey-Fuller test also we have table. I have not gone through the
So
table.
it should be
I'll
less than 10% or 5%, how it is?
any of the value.
So I can normally we'll take maximum, right, and less than 10% we
Yes,
have to consider.
yeah,
So
10% for 10, 1%.
and that is
For
three
point
values it is
zero.
there. Let us consider
Yes.
maximum. If it is less than 10, then again the statement we have to say like stationarity kind of thing or different thing.
No, no, we will say if it is less than any of this value,
Hmm.
what I observed from different tutorials and all, that if it is less than any of this value, then we will consider that data is stationary,
Okay.
and we will
No,
check for
even
p value.
I was referring a very good article on that. I'm just searching that. If it is available, then I will ping to make
And
like
what
the
about that
complete.
T
Share
statistics? Whether there it means like any value means we have to compare only with critical value and T statistics. That's all.
That is what it has been said that the
p value. Yes.
thumb rule will be that ADF value we have to compare with this critical value. ADF should be always lesser than these critical values. It is 1%, 5%, and 10%,
Hmm.
and the p value should be less than 0.5. That is the thumb rule for this
That's all.
particular
Okay.
ADF filler.
Okay. Okay.
But
Okay.
why the critical value is 1%, 5%, 10%? I will try to get that article and we'll see to it like how it is been explained there.
Hmm. Okay.
Here it was given somewhere. There is hypothesis for this that we have to deny this hypothesis. We have
Null
to reject this.
hypothesis.
Null hypothesis.
Yeah,
Yes.
Yes.
correct.
If
That
we
is
fail to
p
give
value.
this,
P
Yeah.
value is less
P
than,
value
yeah.
I am clear about it. That other thing, na, that is I'm new. That's why I'm.
This is part of the stats actually.
Hmm.
Statistic
yes,
part. This is
Even
covered. Can you go down?
even in YouTube now they have skipped. They also told like you remember
Hmm.
only this much and just
No, no,
come
no, no, no.
like
We will be talking more like depths of what. Can you go down? I think this is the one I referred. Can you go down? Aman, yeah. So there he is explaining why we have taken 5%, 1%. Correct.
here
Can you click
as a
on?
part of output we get lookup to
Correct,
table to
correct.
determine ADF statistic. There is table for ADF statistic
okay.
where critical values are given like 0.01, 0.05, 0.025. So
So
if we look
lots of
for,
mathematics equation has been done on top of it actually.
Mm-hmm.
yes, it's a part of statistics. So
So any value
for that,
it is okay. Out of three, any
yes,
value if it is less than it will be okay. Okay.
yes, yes. And if our data is not stationary according to this all methods, then we can try to convert into stationary by there are different methods like log transformation, differential. These are I have
Yeah, that is
mentioned
what
it.
I want there because there are a lot of things. Whether is there any based on the trend, whether we will decide which type of transformation we will have to apply, or just try random method we have to like apply and check the value.
We
Is there
have
any
to
thumb
apply
rules
try
I
like that?
and
think,
run.
yeah, each method we need to do transformation and apply to check whether stationary came or not.
So that is trial and error only
we
then.
we can apply any of the method,
And
log
that is what,
transformation also, and
here
differential.
you have mentioned two methods, maybe there may be two more methods also. So
Yeah, they are
my question is when we will apply log, when we will apply differentiation, like that. Is there any like reference point, so that now after
okay,
seeing
you
the value we will say if the trend is like this, we have to apply log. If the trend is like this, apply differential, something like that
got
we
the
can
point,
say.
yeah. On what basis we are applying which of the
Yes, yes.
transformation theory? Okay, okay, that is one point we will note and we will try to explore. Like everybody can go for that option. Since we are now in this stage,
Log, basically, what I know about log transformation is that when we standardize or when we do EDA or perform feature engineering, so when a value is very high, minimum and this mean and variance, we apply log transformation to scale it down. If
right?
like if data is high enough, so we
I will
apply
say
log
I will say
transformation.
one point, Aman. Here log when we will apply is when the trends are like exponential, like the rising trends, like L inverted L shaped
Yes,
trends. Now if that
values
is
are very
there,
high.
if that shapes are there, then we will apply like log, and then it will come as a linear one. The curved L inverted L curve, it will
Yes,
come as a linear one. That I am sure. And coming back to differentiation, how it is like a zigzag, like a sinusoidal wave means, then it will come a straight line, right? Differentiation.
the differentiating I have not visited so much, but
I
what
think
I
that
thought,
only. I think that only. We will work on
yes,
it.
it's shifting the value, and according to that value, it's calculating the difference. Like,
I think yeah, I think sine wave. If it comes to sine wave,
Sine wave, we will apply differentiation.
yes, yes, yes. I read this. This is a sine wave,
this
right? What you showed is a sine wave.
this there it is applied differencing.
Because that's a sine wave. That's the reason they might be happening.
After
If
differencing,
before
it is
trend and after
coming
trend we
the
can see now, then we can say at least okay, this zigzag trend, then it is coming linear like that. So before any trend go up, after differentiating you are showing trend, right? So before they haven't shown any trend.
yes, they must have shown some. This is the trend. It's
So this is
actually
from increase or decline. It is increasing actually. From
yes,
low to high, it is moving. Yeah. So
and
this
it
is
is showing
one.
for both, for log transformation also, and for it is showing different methods to do stationarity to convert it into stationarity. Like seasonal differencing is also there. Transformation, log transformation is also applied.
And guys, like this na differences, whatever you are uh, going through, try to share in the group also, it will be good, because I can see most of the people
I
na,
thought,
like they are going out, okay, out of the topic, and they coming back, okay, and if they miss also, though they can go through that.
okay, I
Yeah,
will
yeah,
share
yeah,
it
sure.
definitely.
No, like I have not seen much, to be very honest. Like till the point I've given it to Aman, no, that was like clear to me. So I have tried that, but now this transformation part is a new thing. Not new thing. Like I wanted to explore more on that.
Yeah.
So definitely, whatever the
Mostly,
reference I
see,
will.
since we got like p-value near to zero now, we are in safer side. But what it is not the case in all the time. Mostly, we will get
No, no,
stuck up there.
correlation is now challenging that part now. That is where like we need to do transformation. That's the reason we are trying everything in the queue. Wherever doubt is there, it is getting over, and then we are reaching towards the modeling part.
Now what I have done that I have applied log transformation on the AQI data,
What is the above code?
and
Above the
this station
26.
above that, this
This.
this is what test statistics
Okay.
p-value lag used is. Lag used is basically after what extent it is showing the similar data seasonality. Like in this case, we can say that after 27, the data will repeat again. That what lag represent.
So here p-value says somewhat different than that top
No,
one.
no, no, it is
Both are same, na?
3.87.
It is
Same. It is.
same. Actually, it is very small. See this
That is minus. That
Minus power 8.
Yeah.
Sorry, I'm
Minus, yeah,
always trying to get that one.
No, no. That exponential e is coming with after 7 only. There it is gone till the 5 part last decimal value. Yeah.
Okay, just we have got that values in list. Okay, next.
Next is what we have applied log transformation. What
Means
we have
why
done,
we are
we
applying
want
here?
to, if we
Aman, put that autocorrelation thing here before this. If you have that code handy, no, from Jupyter Notebook, you can copy and put it here, and bring out that graph for AQI. Yeah, yeah.
P.
Copy the same thing. Yeah, yeah. Copy that. Change the name AQI. Correct. So the auto.
Now it is clear.
For this, I have if it is showing this graph is showing this term, so I have applied this log transformation.
So can you explain
First, I have
about that graph?
converted the
What like?
P autocorrelation and partial autocorrelation. What it shows that autocorrelation shows that what is the lag? Lag is basically after what extent the data will again show the similarity.
It's a kind of
Dependency.
cyclic thing will happen, but after certain
So
time.
before how many steps it has
After
to go
certain
to predict that current value, something like that.
Yes, after what yes step it after like this in this lag used after 27 data. After going to 27 data, then again the graph will show the similar result, seasonality, what it represent.
Okay. Okay. So
Lag value.
no, that in terms of graph, how we are defining, like it is like straight line, and second graph it is like some values are up and down. So that I want to understand, means the shape of the graph.
Graph is basically for the AQI data. We are calculating the ACF and PACF. Here I can show you.
Yes, correct.
ACF try to represent lag, which is after what interval data is going to repeat itself. Basically, seasonality it represent lag value, and PACF represent the error term. Actually, while doing for predicting, if we want to predict for time t, d data for time t. So we have to first calculate what is data for time t minus 1 before that, and plus the error term. Error term is there, and this error term represent partial autocorrelation function. Are you getting my point?
Yes, yes.
Data we have to predict the data for time t. So we have to first predict what is the data before time t, means
T minus 1.
t minus 1, and the error term which leads to predict the time dt.
So
That's that what it represent by PACF.
this is good. Okay, my question is, you are seeing that graph, and after that the graph is not good, and you have applied some transformation, right?
Yes.
So that's what.
I will show you why I have not considered this graph, because if we consider this graph, and here it is the first interval. If we want to take this any interval we can take, if we take this interval 0.2, when data is going downwards and after meeting 0.2, what is the value we consider for ARIMA? We calculate basically for ARIMA, we have to calculate P, Q, and D.
Right.
P is simply auto regression. Q is our moving average,
I
and D is our seasonality or
difference, yes.
non-seasonal differences.
Q is integrity or something.
So for calculating P, Q, we plot this graph. Autocorrelation basically depicts Q, and from P we calculate from partial autocorrelation. And how we calculate, there are various mechanisms to calculate P and Q, but what I learned is if we draw if we take this interval, we can take any interval, and the data
So
which
the first
crosses the
dip it will say like that, right?
yes, which crosses the first interval, we will consider that as Q value. Like in this, if we consider 0.2, and if we go downwards, and after 0.2, what is the value? So I think 1 will be there.
So here the first dip will say -4 or -0.4 or
No,
0.2.
first dip will be first. We can take any interval. 0.2 if we are taking, and then here also we will take 0.2 minus 0.2. And if we draw like this, if we get,
So
I don't have pencil,
that is
but
what, see the line, if you draw na the first point and second point, it is dropping to 0.4 -4, correct? So in this
yes,
case,
yes.
whether you will say like the p value will be minus 0.4 or 0.2.
Here P value will be, I think,
The first dip, as
204.
I also gone through, it is like
Yes,
first
yes.
dip, so it will be like 0.4 minus 0.4.
In negative, we can't take. Here I have to check for it. Actually, it's very confusing.
Okay, and Q value?
No, you share the code on Git. No, we will try to explore this to understand the exact thing.
It is not about code, Sripati, it is concept. Like the first
No,
dip,
that is
they will
what.
say,
Hmm. That autocorrelation, what exactly the graph is trying to say. That day, in a brief way, I have shared one screenshot in the chat, if you remember. That what exactly autocorrelation is doing.
correct. So in both the cases, I think they are taking the first dip. Okay, that we'll see whether if it is going to a negative value, whether we'll consider it or not. We'll make a point. Sripati, 2 points we got it right. Can you note it down so that we will not forget? What is the first point?
No, that transformation thing, like
Correct. Different
what condition we are
methods for
taking,
of
which
transformation.
correct.
And second one is
And
if the dip is going negative side, then whether we will consider it or not.
Yes.
Okay. Okay.
I have not seen any graph going negative side. This is the graph which is going in negative side.
No problem. We will work out. No problem. Go ahead.
And after that, we will go and create a Arima model by simply, this is the method for creating a Arima model and fitting it.
model part we can keep right now aside, Aman. Like
Yes.
No problem. No, it is only right like fit and then see the value.
yeah.
So you can carry on. It is
Here
only
we
that
keep
much of code,
Q
right?
and D.
So did you put it in the current code?
No, I have not put it in the current
Then
code because
put it and try if it is going to run. I thought like you have not.
we are not getting the P and Q value what we should get. So how we can put it in current code?
So this is the blocking point, right? The blocking point is we have to understand the PQ value first, and then we'll head towards the Arima.
Yes, after understanding the PQ value, then model will be ready to be deployed or predicted.
Got it.
And little bit go up. Little bit go up. There. Come down. This is the graph, right? Still come down.
If we increase the null value,
Go to
see
that
what
git one.
happens.
Go to that git one.
Where?
Go to the git which the code you are showing, not here.
Jupyter notebook.
Jupyter notebook.
Oh.
Okay. So here now what I
For
have
this
seen
it
there
was
only.
easy.
No.
For this,
See,
for this it was easy.
correct. This
Because
is
it's
what even
going
I
down.
have seen. So here 0.4 it is, and 0.4 again. This is a good one.
But actually, the I think after the interval it's going downwards. If we are going, I can say from this graph, if we try to model it down, the 0.2, it's like this. We can take one, I think, in my opinion, or 1 or 0 we can take, and we can try it. Like,
And I have seen like there is one more library like Auto Arima. It is there. What it will do is it will try to get us that PQI values
and D value.
automatically. It will like randomly it
Correct.
will go through all the values, and whichever the best fit, right, that will give that value.
It will run for multiple times, and the best one, whatever it is, will be having the value, no PQD. It is going to suggest for that the
We
best
can
out of
try
that. Yeah, that is.
that also, that method.
You tried that also, Aman?
No, I have not tried. We means I'm
Yeah,
not
yeah. No, that code is there with me. I have tried. So we will put the same thing actually. If you want, I can search that code right away. Somewhere in my machine is there.
So that's what it's actually.
So we can say with some few points, Arima approach we can like we have done.
Yes, filling the null values after that, it's very easy task to build model.
Yeah, just
In time
visualize
series,
and then take some decision, apply transformation, and then predict the output.
yes,
So in this code, only few points was left, right? Auto correlation you have to run and try to take values from that, and after that predict the values. Prediction of the values was not done yet, right? For the future
yes,
thing.
yes.
So at least for every model now we will keep that as a like end line.
Okay.
So predicting for
So
next few
what are the models we are trying? Like we have Arima, Sharima, and then what else, Aman? Like, did you explore anything?
even the score also we will keep in the loop, like for every model. Like prediction is one thing, and score also we have to check, right, how it is going to, like we have to split the data and we have to
But time
score.
for time series,
Yeah, score is
model,
important to know which model is currently occurring.
So
for
for
time
that,
series
if
model.
you want to like up to November we have data, December data if you want I will get it. So we will predict December month data, that is also good. Or if you want more, then take 17, 18 and 19 data and predict 20 data, 20 data. That is also okay to see the score, how the model is performing. Because based on that only we can judge which model is good. Hello?
Yeah,
Yeah,
sure.
okay.
We are here only.
That also make a point, so that
So
for
just
each model that benchmark we will make it.
yeah.
And coming, you are asking something like Sripati, other models.
Yeah, just now I pinged in the WhatsApp.
So that's all, or any other Haman you have gone through? So you oh, it's a big list, then it is quite enough, I think. So AR Arima, if we have done, then first two we can skip, first three we can skip, right?
Yeah,
But
actually, it is
still,
in the hierarchy.
yeah, but still, if somebody wants to like come in that sequence to know the scores, how much variation it is coming, then we can like run the code. That is also okay.
Vector
And
auto-regression is for multivariate data.
Yeah, that is what it's a list for all kind of time series, whatever you want to do. It's univariate, multivariate. So based on your requirement, you can opt for it. And the
So
last one, LSTM, is a neural network. That is like totally out of machine learning. It is deep learning thing.
yes, NLP part.
So, Aman, like we will look into each of these wherever like best model can come in the picture. We will decide on that, and in team we will again keep it open for everyone who wanted to explore what are the model here.
Yes, we can keep. So we have to Serimax we have to do for
Correct.
modeling part Serimax, because what vector auto regression is for multivariate data and we have univariate data. So this is okay.
so we cannot do that vector auto regression 3. What are the three
Yes,
approaches? Huh? Okay, and what
yes.
about the other one? SCS?
SCS I have no idea.
No idea. Like these are like been suggested, but never seen. We have to explore like how it is getting
Yeah, even we
used
are
in.
not doing like the one which we are concluding, right? So this is for this model, like that we will
No,
come to know.
generally it is LSTM. Mostly we will see that people are doing, but Arima and Sarima is also like in the league. Like they used to do ensembling on top of it, and based on that, the result is getting published.
But my question is in this data we don't have any seasonality kind of thing, since directly we have approached that stationality. The data is not giving any like seasonality kind of thing.
Seasonality is what we have from lag value. We have calculated the seasonality that after 28 data point, it is giving
It's coming.
seasonality.
Yeah.
Then how come in the first method directly it says the data is seasonal without applying any transformation? It shows that it's seasonality, right? It's stationary.
Yes, yes.
So that is I got confused. Definitely, if
Which
it is
one you are talking?
sorry.
Decular test, right?
Yes.
Decular,
ADM.
right? There it shows it is like a stationary, right? P equal to 0, p value 0.
Yes, yes. It
Yeah,
shows
T
that
stats. Yeah, that's
it
what
is
Ishwar respond.
stationary, but when we applied ACF and PACF, there it shows that it's not stationary. Two of the methods shows that is stationary, and two of the method it shows that it is not stationary.
So what are the two of me? ACF, PCF, and after that
That
DF.
mean and histogram.
Uh, okay, mean
Three of
also we
them.
have tried. Okay.
Yes, mean and variance which we have calculated by splitting it.
Mm-hmm.
And also through
This
graph, we try to see like how the normal distribution happened through histogram.
and another question. This may be because of that missing data.
Yeah, it depends on the data quality. So that is for sure. Like
So
Um,
another question again. Is it okay like if we have like missing data, we will build the model taking the data set like that itself, or how it is?
Here we are dropping NA values.
That's what we are dropping NA values. Okay, so we are predicting some 50%. Leave about it. Okay, consider that we have null values and we are dropping everything and we are building the model, right? So is
Yes,
it
yes.
okay like that or not?
Yes, it's okay. I have
It's
seen
okay,
some
right?
of the approaches
Mm.
after doing the log transformation.
Mm.
There are values which are null. So what it is doing, that they are dropping the null values, they are not considering the null values, and they are applying the values which are existing, and they are dropping the null values and building the model.
Okay. So, Sripati, in that in this Arima itself, we have covered the 3 points, right, which you have highlighted: seasonality, autocorrelation. What about the other one?
Stationarity.
Stationarity. So 3 things we have covered. Good. So like
Correct.
these 3 things we have to like no need to repeat for every model, right? These things will remain always same.
Yes, yes,
Only thing is
Yeah, yeah.
the last part we have to like modeling part we have to use that model and predict it.
yes,
You
yes.
have to see the accuracy, how it is coming with the
Correct.
individual models.
Mhm.
And also we have to see confusion matrix here, like Aman. So that also we will have to check, right?
But what I observed, that for classification model, we have F1 score, precision, accuracy. For regression,
Mm.
we have mean, squared error, mean.
Mm.
Likewise, for time series model, we have
RSS I have heard about here. They have RSS residual sum of squares. Okay.
yes, it basically plot it, and there are three methods to the
Even
accuracy of the model.
RMSC also they are doing, and even RSS also they have done. I have seen those two approaches.
Yes, yes,
So we'll
residual
keep it
score.
apart for the last part. That is what that will come in this
AIC,
picture. But
BIC, and HQIC are the three parameters to uh,
validate.
check for the accuracy or which model is best. I don't know about these
AIC,
parameters.
can you expand so that at least we will remember, try to remember the AIC?
I will share the document
Okay, that is
AIC,
also good.
BIC, and HQIC
Mhm.
where it has given. In WhatsApp, I will share those document.
And can we able to apply that cross validation which we have discussed in the last meeting here? Like it will like try to
No,
run multiple times and take the average of different methods, different
no.
models.
Cross validation is applied to train and test split data.
Only, but with different models, right?
Yeah, for machine learning models, like for classification and regression model.
Not time series.
So here we are not splitting data. No, that is what we are taking data and directly it is.
Okay. If it is only concerned with splitting of data, then we can split first 50% or first 70% and last 30%. Like that also we can do, right?
For, I have no
Like
idea
I
about
have
that.
never tried that, so we
Okay,
can give a
okay.
try.
We will
Yeah.
like make a note, and after that everything over we will try to. Because
Mm-hmm.
since it is
Not seen
automatically
anything.
trying multiple times, right? So it will be handy.
Mm.
That's what I'm idea.
I have seen for time series, if we are doing LS from LSTM, then we split the data. But for
Mm.
this Arima and Sarima, I have not seen data splitting of data.
Yeah,
No,
data's
that is where it's having a dependency on that PQD value. Aman. That's the reason they are not
Yes,
taking that splitting part, like
splitting the
train test.
data.
Yeah. But LSTM, yeah, there it will be neural network. So again, there will be hidden layer, right?
Yes, yes.
That back propagation, forward propagation will happen. Optimizer will be there. Activation factor will come. So those things will come in the picture. So for that, we need two sets of data.
Yes.
So, Sripati, can we like repeat one more time, highlight the points which was done? It is okay, everybody understood, but which was like had to put in the code, right? If you like highlight, then Aman or Nayak also now free. He also wants to work in the modeling, so they will
Mm-hmm.
try to concentrate on that one and come with some output.
Yeah,
So.
so as of now, with the fresh data, what we have tried, we have like taken the data, filled up with the 50% of that 35% missing data, and then that value, whatever it's been filled. And then on that, we have tested the stationarity of the data by mean variance thing, and then using a decay Fuller method, again we have tried to establish relation with the autocorrelation thing, like plotting the graph and validating that whether data are autocorrelated or not, and it was not showing up. Then I think Aman has applied the transformation method, like log transformation method there, and still that transformation topic is open now. It is not like getting closed. So whatever the transformation options we have to go through each of them and can be validated on the code as well. And whatever we are getting the result out of it, we will be sharing in the meeting. And second thing is like how autocorrelation is working. That is also we have to deep dive, like what is the relevance it's coming, like the lag term it's getting used here, like every 28 like lag of 28 we are seeing the repetition kind of cyclic situation is coming. So those things we have to explore and come with more concrete understanding on the theory, and then how it is getting applied in our model as well. So that is where we stand. And again, deciding on the models we are going to validate, like already Arima, it's been little explored today, but along with that Arima, whatever other univariate models are available, like Sarima, Sarimax, and then LSTM, all these things we will keep on exploring and try to bring in the code at the earliest. That is the plan.
And
If I'm missing anything, you
considering
can add.
one model, right? We have left out some models like predicting the values, or using that auto correlation thing, not auto correlation, auto what repeating number of times. It is predicting the not predicting, getting the best fit PQ values.
PQD.
PQD
that
values.
Is part of Arima.
That is part of Arima. So that part we have to implement, and after that predicting the values, it is yet to implement, and after that getting the scores, that is yet to implement for one model. Okay, then the same thing will be repeated for others, right? Anything it is missed in that.
So score part, like I missed it. So if score we will be checking, and then we will be comparing with other models also. That is the plan, right?
Sir, I have one doubt. P value and Q value we are calculating.
Your voice is very low, Nayak. Be loud.
I have one doubt that we are calculating P and Q value from ACF and PACF graph. Then from where we can calculate the D value?
The mean value, root mean value.
D value is D value is basically non-seasonal differences. I have not. I have built only Arima model, not IE model. I have built ARMA model, and D wherever I
ARMA.
Yes, and where I have seen they have taken D is equal to 1 only. This is difference.
So that is where now you have to come in action. Start working on model. Start exploring Arima. Try to put it in the code and see the result, and then share with the team. What do you say?
Okay, sir.
It's okay, right? Don't feel like
no, he is very much interested. He is asking me, sir, why you are giving that task? I want to do modeling task. He is asking me.
So no, that is why it should not, because I've reached Aman directly, because Aman shown some interest earlier, and after cleanup he was also talking about LSTM and all. If Subrat, you are also okay with that, then definitely we will be in touch and we'll start working on the model part. And then it's open for everyone, like Narayana. Pranit, where are you, Pranit? Like, you are not at all opening your mouth. Where are you? Pranit?
Pranit, unmuted, but we cannot able to hear you.
Hey, come on, speak up, man. It's not going to work this way.
Today only you are silent.
Pranit, any hesitation? You can speak up. No problem.
No, I think some issue with his network, something. At least else you'll have some sound, right? Little bit sound also.
Yeah.
You have some audio or mic issue.
Okay. So So Narayana, you can also now pitch in on this part because your
Yes.
task is over. You
Yes,
are
sure, sure.
out of that Shivani's kingdom, so you can work independently and whatever you want
Yeah, sure,
to
sure.
do, you can do it.
Yeah, I will also check that one of the model. I will two models are. I will
Uh,
take that models.
now we are working
We'll
on
explore.
univariate data, so
Yes.
the key point will be that we will be targeting those models where univariate is getting applied, and
Okay.
we can come with multiple options. We have like we can keep a couple of days for this as well for exploring
Okay.
all the options and also putting it in the code as well, like not
Yeah,
with
sure,
the
sure.
theory part, but practically we will prove like how things are moving.
That's true.
Yeah. So
Yeah, sure.
is it okay?
Yeah, it's good. Yeah, you have come up with that approach. As that is enough. They will try to
Hmm.
Google it, YouTube, whatever it is, and they will try to implement
Hmm.
that code and see the score
Hmm.
and come up with. Okay.
Now the data is also clear. There is no question on data part,
Yes.
and things are in our hand now. Everybody can start contributing on model things and explore as much as you can. Like what are the best thing can be done.
So, and we will not drag this meeting for another 2 days. Okay, we will try to keep it more frequent. So, when
Hmm.
we will suggest, when we will keep this meeting again?
Like today is Wednesday, Thursday. Let's again meet on Friday. That is what we can do. At least a day it should be given if it is okay.
That is up to all.
Okay.
Means,
Okay. Okay.
so, and Saturday we have meeting, right? That is okay.
On Saturday also, on for Saturday also, I need to prepare some code. Right? Of course, we have existing only. Just I'll prepare sample, like a
Yes, I
keeping
have
some
prepared the
codes.
code, right? In that,
The
try
same
to
thing. Yeah,
delete
same thing.
in between whatever code it is there. You
Yeah,
delete and
not
keep the
required, and we'll keep the short, short one to
And
show.
the codes are there on Git now. Like whatever the
Yes,
code's
yes,
been worked on, everything
yes,
is on Git now.
yes, it is there
yes.
in
In the
Git. And
code.
Okay, okay.
Naik,
Even
you got that
I
access?
yes, Mike
Uh,
was telling last time, no?
Naik and Praneeth, you both only complained that you are unable to see the files and that.
Even I missed to put whatever. But anyway, now Aman has integrated few things on that. So Aman, you can add that one, the one I have given in the morning to you. That will be the
Yes,
final
yes,
code to take it further, right? So
yes.
put it today itself in the Git if you have time.
And Subrat, actually, you saying right, some code we are giving assignment to you, right? Because we cannot give completely to them, so that's the reason I picked few here. You can take the same code which we have, right? Which Ishwar has
It is
Why
for
why
the
provided.
you both
namesake.
are separating? You internally you coordinated and you are doing and you can present like that also. That is okay.
Yes, yes, yeah. That also, yeah. That's better, I think.
You
So
can
we'll
cover Narayana, Subrat
yes.
also. No
So
need to
yeah.
have individually showing up things.
Okay, that will do.
Hmm.
I will do that.
Praneeth, still you are listening us, you are trying to speak. Anything is going on your end?
I think his mic problem definitely.
Yeah.
Looks
No
like.
problem.
Otherwise, by
Praneeth,
this
you
time.
try to take some of the methods and try to work on it and come with some solution. At least you
Fine,
can
fine. So
say,
we can
at least
wrap
you
the
can
meeting
say
today.
yes. Yeah, that will be good.
So the
Good, we will
next
meet on
plan will
Friday then.
be, yeah. Try to explore as much as you can. Transformation is there, autocorrelation is there, score part is there, and the model selection we will do. So try to do whatever in these areas everybody wanted to do.
Yeah, keep same thing in WhatsApp also so that people will not
Okay,
refer
okay,
you.
I'll put that. I'll put that.
Mm.
Yeah, sure, sure.
He has some mic problem. He is
Yeah, it's
listening.
okay. It's okay.
Next time we will be having some good
He
mic.
will lead next meeting. Friday
Yeah,
we will start
next
with him
meeting. Pranit, correct. Pranit will be showing up the things.
hosting the
Pranit, be ready.
meeting.
If you are hearing us, be ready for the next meeting. At least he can put in the chat. I think he has put.
Yeah, I'm ready. Okay, good
Uh,
to go then.
he's ready also. Cool.
Mm. Cool guys, then see you then.
Thanks everyone.
Bye.
Thanks
Bye.
Good night.
Aman
Okay.
for doing
Bye.
things,
Yeah, thanks Aman.
and thanks
Today is
Subrat
his show.
also. Yeah.
Yeah,
So
Good
we'll meet on Friday with new things.
yeah. Bye.
Bye bye.